Hello, I'm here with Caitlin to talk about falling junk. But first, there is a interesting new scary Mac flaw, iOS and Mac OS. It is yet another speculative execution flaw. And once again, you can execute it by, I think, JavaScript. So by getting you to go to a malicious page, they can slowly pump the secrets out of your box and expose your passwords and other data that you've typed into a web page that shouldn't be visible. And Apple has no patch yet. And it affects you if you're using Apple Silicon, which I think is the M1 or the M2. So, it's not ridiculously powerful. It takes some 5 minutes to profile the machine and then 30 seconds to extract a 64 character string. So, however, I'm sure an intelligent social engineer could trick you into opening a page and not noticing what it's doing for a while. And So it does seem like another thing they'll probably have to patch, although there just seem to be an endless chain of these speculative execution flaws, one after another. Anyway, now let's hear about the space junk.
So space junk is apparently not good for the environment. So it turns out burning a bunch of metals and stuff in the upper atmosphere is not good for the upper atmosphere. Let me throw up the article here. So
it's surprising to me because there aren't that many tons of space junk. I mean,
there isn't. So and space hardware is usually very hollow and thin, and they try to make it as light as possible. But
it would seem like you do a lot more harm to the atmosphere sending it up with all the rocket exhaust.
It depends on the type of rocket.
Okay.
I'm hydrogen, oxygen, hydrox type engines. Those release water vapor.
Okay.
A kerosene rockets, not so much. But anyway, so Live Science has an article here by Harry Baker, which sounds like a spin-off to Harry Potter. Anyway, so what happened is that some researchers flew a plane through the upper atmosphere and found a bunch of elements that are associated with burning, space debris. And so basically what's happening is that we're littering our upper atmosphere with metals like aluminum and lead and a few other metals and toxic chemicals from our satellites that are burning up. And it's basically staying in the upper atmosphere, which might not be so great in the long run. We don't know yet. More science needs to be done.
How much heavy metal can the air actually hold? You would think it would just fall out.
It's like atomized bits of aluminum and stuff. So I would imagine quite a bit. I mean, if you're talking about the entire Earth.
And what harm is it going to do exactly? We're not breathing it. Is it going to affect the warming or something? I mean,
no, we don't know what the implications are, but it is changing the environment, and so we need to think about that. And if it turns out that these metals and pollutants are actually destructive to the environment, this is going to make space junk removal much more difficult.
yes. Well, I don't think there's any other choice. Okay, well, anyway. All right. So it sounds like they haven't really figured out that much about what it means yet.
Nope.
Oh, okay, fair enough. Well, anyway, so there's an article on Yahoo Finance, which they got, I'm sure, from someplace else. Saying from Fortune, Elon Musk lost 28 billion as Tesla stock fell, which certainly it should have been falling for the last 5 years based on fundamentals. But anyway, they're saying now the Toyota leader says people are waking up to the reality that we can't really switch to electric vehicles so rapidly, and it's not really the answer. And he says there are many ways to scale this mountain. And I must say, I think he's right. I'm watching the so-called electrification of the car fleet here in California, and it's ridiculous. The power grid is not even more than a quarter strong enough to charge all these cars. The adoption is terrible. I live in a place with hundreds of apartments, and there is zero power anywhere near where you park a car, and nobody cares. Nobody complains. There are no plans to add any charging ports anywhere. I go to a mall where there are like 5,000 spaces, and there's like 10 charging spaces, and most are usually sitting there empty. It is not happening, not as fast as they think it's happening. It's as a misbegotten California government scheduled to try to push something through without really thinking it through. I think more efficient gasoline engines are the future for the next couple of decades, whether you like it or not, and or something else. Anyway, it's interesting to see the first significant voice I've heard on the other side as we race into this electric car thing without, I think, really thinking it through. Anyway, let's go back to you with Hardware Hacking Lab.
So this might be good for the students to take a look at. Void Star Security has a blog post up talking about setting up your first hardware hacking lab. And it goes over a bunch of products that you might want to get, starting with desks, workbenches, essentially. Now they're very big on IKEA here. I actually recommend instead getting a glass tabletop as opposed to a wood one, but anything works. And they talk about ESD protection, hot air stations, soldering irons, oscilloscopes, logic analyzers, multimeters, JTAG adapters, various single board computer interface tools, fault injection, basically everything you would want to get a beginner lab up and running. Now, I do have a complaint. Some of the hardware listed is not really good for beginners. So if you look at the oscilloscope section, you'll see that there's one here that is $60,000. I do not recommend buying a $60,000 oscilloscope for your first oscilloscope.
Can't you just get a dongle that feeds the signal into a computer? That would seem to be the modern oscilloscope to me.
There are USB oscilloscopes. I don't recommend them, actually. I recommend getting a regular oscilloscope. But you can get, so this one is $400, which is more reasonable. You can also go on eBay, find used oscilloscopes, if that's an option for you. I'm tight on space, and most used oscilloscopes have CRT displays that are just huge, so it wouldn't work for me. But you can get basic oscilloscopes for $200 to $400. New.
What's wrong with the USB ones? It would seem like the computer is right there. Why would you reproduce so much of the computer's functionality in a separate piece of hardware?
Just in my experience, the software is not that great. And these oscilloscopes already have like USB out and stuff. So if you want to get the data to your computer, you can.
Yeah.
But you're talking about setting up in a lab environment. So it is kind of annoying to fill around with your computer and get the software set up and everything. It is nice to have a standalone, box that you can take around with you and move and adjust as needed.
All right.
Just from a practical perspective.
And you can fund it by breaking into Bitcoin wallets.
Yes.
Yeah, well, we've talked for years about it'd be nice to have a hardware hacking class at our college if things are more functional. But anyway, doesn't look like we're going to have any new classes for a while. Anyway, in this, I actually got a couple things about hardware, which is not my long shoot, but they've developed a new fuzzer to fuzz chips, and they found a bunch of 0 days in the RISC-V chips, which not that RISC-V is worse than the others, I imagine. The others probably just haven't been fuzzed with this new technique. They say the existing fuzzers are ridiculous and extremely ineffective, and their new fuzzer is greatly better. So this article in the Register talks about it. So that sounds quite plausible. And like I said, for the first one, they're still finding speculative execution bugs. There's a lot of flaws in processors. And this one is pretty amazing. Apple, the new iPhone, has another problem. If you charge it in a BMW, it turns off NFC, so you can't use Apple Pay anymore. And I don't know how that happened. There must be some special negotiation with the charger going on in BMW that has a bug. But anyway, that would be really mysterious to me if that happened. You charge your phone and Apple, and that box doesn't tell you what happened. It says Apple Pay has not been set up on this device when it has, which would be pretty disconcerting. So that's something that would get people's attention. And anyway, you got another hardware one about the Snapdragon.
Yeah, so for a while now, people have been pretty amused at Apple's new Apple Silicon chips because they're so fast and
yeah,
they don't use a lot of power, and people like it. They think it's great.
Yeah, I like
so
mine.
yeah, inevitably this is going to come to the Windows world apparently. So Ars Technica has an article by Andrew Cunningham talking about the Snapdragon X Elite PC CPU, which has, it looks like, let's see, 4, 8, so it has about 12 CPUs, 12 cores, and is apparently outperforms a bunch of the i7 chips. So this is a high-end desktop processor running on the ARM architecture with Windows in mind. So this is the first time we really seen a high-end performance ARM processor aimed at consumers for Windows. And this will be coming out in 2024. It has a GPU, which looks very interesting as well. It is considerably faster than the i7 iGPU. So this will also be very good for games and game consoles. Yeah, so things are looking very good for the ARM architecture at the moment.
Yeah, and so there will be Windows PCs coming out to compete with the Apple M1 and M2.
Right.
And M3, which I guess is supposed to come out like next week or something.
Right. And then once this battle with Intel is over, we're going to have a battle between ARM and RISC-V.
Yes, which apparently is heating up already because of China, because we
Yes.
blocked China's access to stuff, so they just moved to RISC-V.
Yeah, no, and a bunch of the Western companies here are already gearing up to switch over to ARM5 for their like IoT devices and stuff. Like it's taking off. It really is.
I'm interested in this from a purely business point of view. ARM has the installed base and the front leader advantage. So it is up to them. If they can make smart business decisions, they can stay on top. But if not, the disruptor will tear them down.
Right. And one of the reasons why RISC-V is taking off among IoT developers is because it's such an open platform. They can create their own silicon really easily. So if you have custom specifications for your chip, you can just throw a RISC-V CPU on a FPGA, add whatever extensions you want, send it to a fab, and then now you have custom chips for your product.
Well, sure, but I think that's probably a small market compared to people that would just like to add software to an existing chip. And those people would want to have all the drivers and everything and support already, which is usually how you make it. Even though you have to pay more, the standard product usually means more efficiency for your company if they manage the business right.
Right. Now the thing is that with all these new products coming out that are using RISC-V support, software support is going to go up. So now markets that don't necessarily need that, customizability that you get with RISC-V will now have the software support. And, like I said, it's going to start heating up pretty soon.
Yeah, well, so RISC-V is not going to die, but it's going to be the early adopters are going to be the highly technical companies, not
Right.
the highly profitable mass market companies.
No.
Yeah.
No. So the highly, so a lot of the companies that are producing goods are going to be are already adopting RISC-V, including United States based companies that need that level of customizability.
So what is it that I'm likely to buy in the next few years that would have a RISC-V in it? Cell phone?
I don't think cell phone, but I do think if you get like a refrigerator that has a CPU in it, like a microcontroller, that's going to be RISC-V.
The useless devices will be useless with different hardware.
Right. If you get like any sort of IoT device, like a router, a little camera, whatever, that's probably going to have RISC-V within the next 5 years.
Yeah.
And like I said, and that's going to get a lot of support, get a bunch of software support going. And then once that software support's there, then we'll start seeing in more general purpose devices like smartphones and PCs. That PCs and smartphones will be the last thing I think we'll see RISC-V in.
I just say this reminds me of Linux on the desktop, like in 1993, when you
I'm not talking about Linux on the desktop. Okay, yeah. This is very different. This is like saying Linux on IoT devices, which absolutely happens all over the place.
That totally happened. You're right.
Yes, and this is what's happening with RISC-V. We're just throwing it on all the sort of IoT devices.
But what is the huge advantage over ARM? Is it really that much cheaper? Is the processor price really that significant a thing?
It is cheaper and easier to customize. And so if you're building hardware and you need a CPU or a microcontroller that's custom to your specifications, RISC-V is currently the way to go.
Because ARM, you can't customize ARM because it's proprietary.
It is proprietary and
And
more difficult. Yeah.
people all want to make custom their own processor. I would never want to do that.
You don't want to start a processor from scratch. That's definitely something you don't want, but you do want to add extensions to your processor. And ARM actually, not ARM, RISC-V will actually let you specify what type of processor you want and what sort of instructions that you want on it.
Wow,
So
so
you
you can
can,
add all sorts of entertaining new processor bugs.
yes, exactly. There's so many new bugs just
Let's
waiting
add more
for us.
speculative execution and
Yes,
stuff to the processor.
exactly. Exactly. In
Well,
fact, one of the things that's really slowing down ARM-V adoption right now is that you can have two ARM-V processors that are just like completely different.
that okay, I remain very skeptical. This sounds like madness, but
Like I said, from a hardware perspective, I think RISC-V has the brightest future, but it's a long ways away, very long ways away.
well, if I was the design manager or the security manager, I would say, why don't you just stick with a standard chip like ARM to avoid driving us all insane with the consequences of having to develop your custom processor and support it?
Well, no. So RISC-V is actually more standardized than ARM, even though you can customize your CPU to have, to not necessarily support every single feature that's available to RISC-V.
But if you can't wait a minute now, how is it you can't customize ARM and yet there are more versions of ARM?
ARM has been around for a while.
Well, I don't know much about hardware. It all sounds totally bogus to me.
Yeah, no, I mean, I've had this issue where people are using like older versions of like 32-bit ARM, and then you have like the ARM,
Oh, there's old.
various other versions of ARM. I mean, the same thing is true with ARM, but with RISC, you can be like, I need this specific RISC chip to this specific, specification, whereas ARM, you just sort of license out the version that best fits your need. Like I said, I think RISC-V, especially in the IoT department, has a very bright future in the immediate future, but it will take decades probably before we see it on the desktop or even in smartphones.
All right. Well, we'll see what happens. I just want to, an article at SciTech Daily that I thought was very interesting. Google has unveiled a new form of quantum teleportation. And this is important. I've read several articles over the last 2 years. We're finally understanding this mysterious process called the collapse of the wave function, where things stop being uncertain and become certain. Now, a century ago, when this was all invented, they said it's the wave function collapses and quantum uncertainty is now gone. And that's it, without really explaining why. And then there were arguments about Schrodinger's cat and stuff. And people said, wait, exactly what constitutes a measurement? Perhaps it is human consciousness that must be the measurement. And I said, that's garbage. It's just interaction with a system involving a lot of atoms is what constitutes a measurement. But the fact is, we really don't understand what a measurement is in quantum mechanics and what causes that collapse. And several people are really narrowing it down. And what Google has done here is make a group of something like 70 or 80 qubits, 70 qubits all entangled. And then they interact with one probe qubit to do the measurement. So the measurement itself is done at the quantum level with a single qubit, and they tell if the wave function is collapsed by the change in the noise. And they're therefore able to really get details in this process when you move from the entanglement and uncertainty to no more entanglement and no more uncertainty. And what they found is if you have two qubits that are far apart and you measure the qubits in between so their uncertainty goes away, that increases the entanglement of the ones on the edge. So you're able to sort of freeze the quantum state of the ones in the middle, making a more strong coupling between ones on the outside. And this may have applications eventually, but immediately it's just fundamental physics. We're beginning to actually get some clue what actually happens in these quantum mechanical transitions that have always sounded sort of like waving your hands and doing magic, where suddenly, poof, it's been measured, so it's not quantum anymore. Now we're actually beginning to see what's really happening in there. So that's really exciting fundamental physics anyway. So that's the last one I wanted to mention. And Caitlin, you should probably explain that background, which puzzled me and many others.
I don't know why. It's Moopsy. It's Moopsy from Star Trek.
Moopsy. I do not know Moopsy. All right, well, all right. Okay.
Edition Moopsy.
Okay, well, that's apparently sufficient explanation. All right, well, that's it for this one, and we'll have another one on Tuesday.